Welcome to the Artificial Intelligence Podcast with your host, Dr. Tony Huang. Today I'm with Bob Van Luijt. Bob, do you want to give a quick background about yourself?
Yeah, sure. So my name is Bob. I'm one of the co-founders of Weaviate. That's an open source vector database. And the vector databases, came into prominence because of the whole AI or machine learning boom, if you will. And we're probably going to talk a lot about that. But I'm at it for a couple of years already. I think this is the fourth year or something. So it's a no, fifth, even almost fifth, because we started in August 2019. But it's all in the wake of machine learning and nowadays what we call AI. Before that, I had my own software consulting company. So started as an engineer, turned into consulting, and that's kind of how I started my career. I was proud of myself to say that I never worked for a boss before. So but working in software for a very long time already.
Oh, that you're so lucky. Like I've been in corporate for so long, that like, you've been long enough where like there's a concept known as like leadership worship in corporate where like you're gonna have to follow whatever it is that your leader tells you. It's so annoying. So I'm very envious about that.
Yeah.
So like to start off, like, could you give like a simple explanation of what generative AI is? I mean, that's like the hot new thing that's happening right now, and like how it differs from other types of like data science frameworks.
Yeah, sure. So I think so. The first thing is to unpack is that nowadays when we use the term AI and machine learning, we kind of use it interchangeably. But purely technically speaking, from an academic perspective, AI is something different. But nowadays we use it interchangeably. So that's like when we say AI, we basically nowadays mean machine learning. And to answer your question, we kind of need to go back to 2015, 2016, when there was this new, especially in language, also in images and in audio and those kind of things, but mostly in language, there was this revival of a machine learning. And basically, the first thing that happened was that people try to figure out, can we somehow get an understanding of language with machine learning? And the reason people did it with machine learning was because there's this concept where people believe that when you look at language, that words that have a relation to each other, they're closely related in a sentence. So a very pragmatic example of that is that if you have the two words, the Eiffel Tower, right? The two words Eiffel and Tower, chances that you find Paris more closely in a sentence to those words is that's just more likely than finding, I don't know, Detroit nearby, right? So that's say there's a correlation between it. And so people started to create ways of indexing pages. And the problem that people had back then was that if you wanted to make a prediction of how words were related, and you in a brute force kind of way needed to calculate that, so you had to go, for example, to the whole Wikipedia, let alone the whole web. We'll get to that later. But you had to go to the whole Wikipedia to figure out what the relation was between Paris and Eiffel Tower. That took days to calculate. So it was just very impractical. And that's where machine learning entered the stage. Because we said, well, we can actually train these models to make predictions based on these words. And the first output that these models had were vector embeddings. And for a layman's person, if you look at it, it looks very weird because you can back then we were still talking about single words. As I always like to say, like now we have the large language models that were kind of like tiny language models, if you will. And these words, they outputted a vector embedding. And if you look at a vector embedding, it looks a little bit like coordinates. It's not in 3 dimensions or in two, but like many more. But what these models did was that they tried in space to relate these words to each other. So for example, if you would have the word Eiffel and the word Paris, that would be more closely related than Eiffel and Detroit. But the beautiful thing that people started to see, and we are kind of part of that wave, was, hey, wait a second. if we can make relations in these words and in sentences and in paragraphs, and these embeddings come out, we can, if we do that in a reverse order, we can do search. We can create better search and better recommendation systems, because it's important to bear in mind that if you store data, regardless what your use case is, if you want to retrieve that data from your database, back in the days, the only way to do that was searching for keyword matches. So if I had a sentence that said the Eiffel Tower is in Paris, then the only way to retrieve that sentence from my database was searching for Eiffel Tower, Paris, or a combination of those three words. But if I would search for something like landmarks in France, we had a problem because that was not in the data set. But now the model, because of these vector embeddings, these coordinates, if you will, they were able to match exactly. We don't have an exact match, but we have a very similar match. Now, out of that, a new innovation came as well. And that people started to say, well, so new architectures, entered the scene, like people might have heard about like transformers and those kind of things. But what started to happen as well, that people said, well, if we can make in language these relations, maybe we can also do some prediction in sentences. So we can say, for example, the Eiffel Tower is in ... And then ask the model what's on ... And then the model might say Paris. And that is generative AI. So we started to generate content. And now where we are today is that we can nicely bring these two things together. So we have these models that take care of that vectorization. We have machine learning models that take care of generating. And then in the middle of that, to glue it together, we have a vector database like Weaviate. So what can you do with that? So you can say, for example, let's say that you have a list in your database of reviews of landmarks in the world that you can visit. Then you can ask the question, make me a comprehensive list or a tour guide for great landmarks when I'm in France. And it vectorizes that, gets the right entities from the database, sends like, hey, generate something for me based on this information. The thing that we call it today, that's called, the technical term is retrieval augmented generation. So we augment what we retrieve from the database by generating something. And that's kind of where we are right now. And that's what find people so exciting, because when ChatGPT entered the scene, ChatGPT plays a role here. People are like, oh boy, that's awesome. But the problem was like, I have a lot of data. People, companies are like more than, I believe it's like 90% of data is behind closed doors. So people say like, how are we going to get all that goodness of generative AI that we've seen with ChatGPT, but with our own data? And that's where these vector databases play a role in combination with these vectorization models and these generative models. So that's like the history in a nutshell.
I remember when LLMs became very popular, that vector databases started popping up because like you needed a way to query like information that wasn't like trained on from like that the model wasn't trained on. And so like these vector databases came into fruition. Now there's like LLMs that are very, very capable, like frontier models that are very large, that have very large context windows. Like, what's your opinion on where vector databases sit in the world where LLMs have such a large context window? Like, for instance, Anthropic, they have a 100K context window. OpenAI's GPT-4 Turbo has a 128K context window. Like, where do you think, where does the vector databases live in that regard?
Yeah, so to answer that question, we need to zoom out a little bit, right? So we need to first say, so why is this a thing, right? So why do we look at that? And that is because people try to answer the question like, what's the most efficient way to store unique information, right? So so a very simple example might be, let's say that you are a bank and you have bank statements and you want to do whatever you want to do with Gen AI with these bank statements. Of course, if you ask the model, what did Bob buy in December 2024, the model is going to say, I don't know, because it's like it's not in the weights, right? It was not trained on that information. So now the question is, how do we bring that information to the model? So one way of doing that is putting it in the context window, right? That's option number one. The challenge with doing it in the context window is that, and there's some nice research on it, is that the longer your context window becomes, the less accurate the end results become.
You're talking about
So
the fuzziness in the center, right? Like where
yes,
the front and the rear are very crystal clear, but then the center becomes fuzzy because of the way that the neural networks are built.
yes, exactly. And to understand that, we need to go back to what people refer to as hallucination, that it makes a prediction on word after word after word after word. And what's important to know is that the longer we make the context window, the bigger the chances that it makes a mistake in these predictions. And as we have all seen with hallucination, if the thing goes off the rails, it goes off the rails bad, right? And so that's a problem in the context. So maybe storing it in the context window is a suboptimal solution. And I'll place a little asterisk there because I'll get back to it. Another way of doing it, and that's like a very novel way that people are now researching, is like, can we adjust the weights themselves? So if you Google around, you'll find some research where people are saying like, I believe that the example that they have, LeBron James is a basketball player, and then they change it to LeBron James is a baseball player. I believe that's the change they make in the weights, right? So that you basically update the weights to somehow capture that new information. Now, when we go back to this RAG thing, this retrieval augmented generation thing, there's kind of two ways how you can do that. One is what I like to call the primitive way, and another way is the novel way of doing it. And the primitive way is shooting that information in the context window. So rather than saying like, okay, we're gonna have all that information in a huge context window for it to figure out. No. We do make a pre-selection, especially if a huge data set, and we inject that in the context window. That's where the vector database plays a role. But now devil's advocate about that argument is that you can say, well, but didn't I just say that we want to avoid the context window? Well, another way of doing it, and this is actually the original way how people wanted to do RAG, is that the model knows that based on vector embeddings, it needs to retrieve something from the vector database. That's actually, if you go back in time and you see the original idea about RAG was actually that. So if I had to make a prediction, and we recently, if you're interested in that, we recently also on the Weaviate podcast, we discussed this with some people where we said like, could these things come together? So is there a future where we kind of save these weights, maybe in vector representations in the vector database? Might the future of the vector database be not, I'm not talking next week or next month, but year, 2 years from now, might the future of the vector database actually be that it becomes a storage mechanism of these weights? Because the way, I mean, depends who you ask, but the way that we store these weights right now is kind of ugly. We just store them just in binary blobs, right? What if we could make that dynamic? What if we could add what we in the database world call CRUD support, which stands for create, read, update, delete? What if we could give those kind of functionality directly to the model? And now we kind of go full circle. So maybe the next generation vector database actually does that, right? So it becomes the storage mechanism to store the weights from the models that you can real time create new information, read the information, update the information, or delete it.
One of my one of the big reasons why I like Weaviate, this is why you're on the show, is that um is that like I use Weaviate, and a lot of my friends use something similar. And when we first started off with in the LLM world, we started off with like Pinecone and OpenAI, which is like the two favorites whenever you start off with. But then once you start experimenting around, and once you start doing things that are more advanced, you typically move away from those two and you go to something more specific, like, you know, like Mistro or like Llama 2 for LLMs in the vectors database situation, you know, I switch over to from like Pinecone over to you guys for a couple of reasons. Like first off, there's um one of the big reasons why I switched was that there wasn't a lot of like first party support for like very basic things that are more advanced that I needed. Like for instance, if I needed like query like the information from embeddings, I can't do that on Pinecone. Like I have to do some like janky like way to like some type of like third party way to grab that information. But you guys have it like you know, as a first party. So like what made you guys want to build something where you gave the users a lot more control as opposed to like going like full managed like Pinecone where like everything's taken care of, but you don't have that control where you can't do something more advanced like you know as you progress along your like LLM journey, you want to do more and more and more complex things, and then so like you basically switch your stack from like Pinecone to Weaviate or like OpenAI to like Llama 2. Like what made you guys want to build that this type of framework?
So 3 words: open source community. So the majority of features we have come from they basically come from the open source community. And let me give you let me give you one super pragmatic example. So one of the features we have in Weaviate is hybrid search. And the thing is like a public secret, if you will, in the vector database space, and that's this: pure vector search often is not enough for the majority of use cases. Let me give you a very pragmatic example. So if you say, let's say that you have invoices, right? You have invoices in your vector database, and your query is, what was the most expensive product on invoice number ABC123? Finding that information based on that query in vector space will work very well. But not ABC123, because the model was never changed on your invoices, right? So you need a concept that as hybrid search. What hybrid search does, it does vector search to retrieve, to get the information or retrieve the line items, the right line items. But the ABC123 is captured by, in our case, a BM25 index, where it says like, hey, wait a second, that's such a unique thing. We're going to rank that very high. You fuse them together, you mix them together, and now you have a form of hybrid search. That came from our community. It was our community was saying, hey, wait a second. We tried to do this. We had this use case with vector search, but it doesn't work very well because yes, it gets the most expensive line items, but not from the invoices that we wanted it to find us from. So when we started to work on Weaviate, we knew like we have an open source community that will tell us what they want. We have many more things and features in the database that purely come from community. Let me give you another example. So one thing that we have is multi-tenancy support. And in these multi-tenants, you can decide per tenant if you want to store information in memory or on disk. And now you might go like, okay, so why would I care? Well, you might care because memory is expensive. And so what happens here is that if you have, let's say that you have a use case with let me think of a use case I've recently seen. Well, how do you call it? CMS systems, right? So customer management systems, right? So you might have interactions with thousands of customers, and then inside that you might again have like hundreds of thousands of interactions with these customers. If you do a vector search, you don't have to search through the whole thing. You want to do that per customer. So you have your multi-tenancy set up. But the problem is if you add all these data objects and all these vector embeddings together, you might end up into the billions, and storing all that information in memory is very expensive. So what we see our customers do is that say, well, actually, it's perfectly fine if we store this on disk, use disk-based vector search capabilities. And now it becomes significantly cheaper to store that information. How do we know that? Because our customers, sorry, our users, our community, and also customers, to be honest, they told us. But it's always the community first, because it's like there are very smart people in the open source community. They tell you can to go to our GitHub and our roadmap now, and you'll see that all the things that are happening there, that comes from community members.
Yeah, I agree. I think the open source is the way to go moving forward in the Gen AI space. I mean, like there's so much movement happening right now in the open source world. I mean, they're catching up with a lot of the frontier models in terms of performance. There's a lot of features being added that are very specific to like use cases where like there's a big pain point that's being addressed, and it's being addressed a lot faster than like what like a managed service would ever provide. So I definitely think going the open source route is like the best, absolutely the best route. Like take for instance like Llama 2, man, that LLM is just kicking ass right now. It's taken over. Everyone's using Llama 2. I mean, like OpenAI used to be like the number one ranked LLM, and when Llama 2 got released this summer, like everyone switched their code base over to that syntax, and you know, everyone that I talk to, for instance, is just going all open source. So I think the future of Gen AI is 100% open source. We're just a short amount of time before open source catches up with all of the managed service offerings. Um, so I'm curious on your take on like where this market is going. And so like, you know, do you think that there's going to be a new type of like vector database like framework that's going to be built in the future? Do you think that there's going to be some new cutting edge like LLM that's going to be developed in the future that's not just like a larger context window or just more parameters? I mean, those are like two things that I would think of in terms of like LLMs, for instance, where like it would become quote more advanced, like just like, you know, something larger in parameter size, something larger in context window size. You think like there's something big and different that's going to happen soon, or do you think like that's just going to like scale linearly until like perhaps like quantum computing hits, and then there's a different and then there's like a different framework that's going to be developed? Like, what's your take on like the next big hot thing that's going to happen in the Gen AI space?
So that's an excellent question. So my my hot take, if you will, would be what I said earlier, that these databases will evolve to go one step deeper, to focus on managing weights in one way, shape, or form. I don't know what that is yet, and let me tell you what I base it on. So the if you let's take the you just gave Llama 2 as an example, right? So Llama 2, but also Mistral and those kind of things. So one of the things that we're seeing is that it's expensive, right, to run these things. I mean, I was just, I had a hard time running the 70 billion parameter models, because I have access to one a 100 GPU myself. So I just tried to just on my personal account, I tried to stuff this thing in there, but it just didn't work and that kind of stuff. So then people, and then if I even had like a smaller GPU, but I stuffed it like 7 billion per minute, it's just very expensive to keep the thing running, right? So obviously but what is the beautiful thing about open source, people start to experiment. So now we saw all these C++ ports, right? So people take the weights, they port them to C++, run it on CPU, and come up with all these boosting algorithms and God knows what, right? But the thing here is that is playing with the weights. That is, how can we optimally store and search through the weights? And what is a thing? How do we call a tool where we store information and adjust information? We call that a database, right? So now we're like one step closer to what these vector databases are doing. So my hot take would be that that's where things will evolve. Not in the near future, because there's still a lot of research needs to be done, but in the not too distant future. And I also loved your remark about these open source models, because the thing is, if something is released in the open, especially machine learning models, and it might be interesting to double click on why machine learning models, but especially with machine learning models, is that when it's in the open, people will start to tinker, experiment, and come up with other stuff that's very hard to do in the walled garden, because if the community grows big enough, you just need to have one person with a unique genius idea that throws it out in the world, and then everybody can adopt it, right? So the way for these ideas to spread is just enormous in these models, and there will be a tipping point. I mean, that's what I loved about the I'm blanking on the name. It's Olama, I believe. That is like the goal is to have the models run on your MacBook. Yeah, I love that, right? And this is just a matter of time. That's gonna go very fast. So and then if I may quickly double click on my point about these, why that's so interesting for models. That is because I have this thing that I like to talk about, that I talk about, like software technology can be stateful or stateless. That's a way to segment infrastructure. And a database is stateful. So what people pay us for, so we have, in our case, we have Weaviate serverless, we have enterprise dedicated, BYOC, that kind of stuff. What people pay us for is to make sure that the database keeps your data stateful. That if you add something and you come back tomorrow, that it is not gone or corrupted or what have you, right? The thing with a machine learning model is that a machine learning model is more like an MP3 file. So an MP3 file has the problem that an MP3 file has is that if you share it with somebody else, you have twice the value, but it does not mean that in this case the artist can capture the value twice, because I can pay for an MP3 file, enjoy it, send it to you, you listen to it, you enjoy it too, but you're not paying for it, right? And that's because an MP3 file is stateless, right? It's just a couple of bytes organized in a certain order, and if we copy paste it, we have the exact same valuable thing that we can share. Machine learning models are stateless, right? So, and then yes, you could fine tune them, but the thing is that we can download Llama 2 at the same time, have both get a lot of value from it. So the only way to the quote unquote simple way, or the primitive way of capturing that value, is putting it behind a paywall. But now you have the problem that if you put it behind the paywall and you don't want to give it away, then you don't have that greatness of the open source community. So that's the catch-22, that the model providers, especially open source model providers, they need to figure out what their business is going to be. If they're saying we want to have that open source greatness, but we also, of course, are our business, so we also want to generate some money. So it's like that's the big catch-22 of these models. And who knows, maybe merging the models and so the moment that the model becomes stateful, regardless if that's with a vector database or in the vector database or whatever, but if it's really intertwined, the moment that that happens, then the model becomes stateful, and then it becomes easier to create a business or product out of the models. But it's going to be very hard for proprietary model providers. And don't get me wrong, I know a lot of these people at these companies, and these are very, very capable, smart people, but you're taking it up against the open source community, and the open source community is vast. So we'll see what the future holds.
Yeah, definitely. The like I in my opinion, I think like the two hot things that are happening right now is they're taking like LLMs and they're like quantizing it, right? So rather than running it on a GPU where like you have to have these like very large GPUs, like the A100s, the H100s, the H200s, like you can now run it on a CPU like locally. So like, if I don't know if you ever follow like the stuff that's happening on like Hugging Face, but there's a guy named called his like username's like the bloke or something like that. And
Yeah,
he just takes these models and he quantizes it, so and he shares it with everybody. So like you could just take it, download it, and run it on the CPU, which I think is like it is great in terms of like the open source community, so that you can like make LMs a lot more accessible, so more people can use it. And then additionally, like I think the other thing that's going to happen that's very big is we're going to be moving away from these like large monolithic LMs like your chat GPTs, or not, sorry, your open AI GPT engines, your Anthropics, and you're going into like smaller SLMs, where like you can run it on like something that's like a billion parameter or like 300 million parameter or something smaller. So I think, in my opinion, I think that's where like the industry is headed towards. Like what's your take on it? Like I was at like Databricks the last year, and like the big hot thing that everybody was talking about was like small language models, quantization of like the large language models. Like what's your hot take on like the, what's next? What's the big hot next thing?
So, so, so first of all, so yes to all the above, right? So, I'm a big believer in um, that people keep innovating on these types of technologies until the tipping point of good enough is reached. And what do I mean with good enough? Good enough is that you just run a high quality model. You just it might be packaged in a Docker container, it might be packaged in any other way, and like you do like your Docker Compose up to run Weaviate, it just has the model next to it. So that is like what I mean with good enough, and it just runs, for example, on your laptop if you're developing. And people will just keep pushing the boundaries until they get there. So quantization is a way of doing it, right? Trying to boost the token generation. So what we see now with the C++ libraries, they have like a handful, I don't know all of them, but a handful of these boosting methods and algorithms. People will just keep going until they get somewhere. Or people might find another architecture where they can do it faster. Or, and this goes back to what I previously said, and this is where my bet is, right? Is that people, because if you take a model, if you port it to C++ or you quantize it, you're already tinkering around with these weights. And I think we're going to see very soon that people just going to unpack the weights somehow, right? And make relations in not relations. They store these different they store these different weights, and then they start to manipulate them, right? You can say, well, this combination of weights leads to X, Y, Z. So let's see if we can change it to A, B, C. And that's a little bit farther out, but we can already see the first research that's happening in that space. And again, I think that's the steps that are going to be taken. The open source models, a lot of people are tinkering with it. They're quantizing, they are porting. That's not a lot of steps removed from tinkering with the weights themselves real time. And this also goes back to, if you talk about real time, so there's no system, I mean, in reality, where real time means 0 milliseconds or nanoseconds, right? So real time means, I don't know, 20 milliseconds or something, right? So if we can do all these things, all these back to these CRUD operations on the models, so create information in the model, read information from the model, update it, delete it in a handful of milliseconds, we've reached that tipping point of good enough. And I mean, we're contributing in our way, but I can't wait and see what the community will do.
So I'm curious on your take on like tips and tricks on how to use Gen AI with like vector databases. Like, have you seen any like projects where or like you've been helping a client and like it just fails completely because they have a like the wrong knowledge coming into that project? Like for instance, I'll start like I was helping somebody build out like an LM vector database this general LM architect, and they wanted to take a like a document and shove that document into one embedding, and I was like, that's not how it works, but they still wanted to do it, and I didn't know how to explain it to them. Like I explained it to them, but they wouldn't understand. I didn't know how to explain it further to, like, because it didn't make any sense to me. But why they want to do it. But like I was helping them do that, and obviously you're shaking your head, just saying that's ridiculous. Like that's not how a vector database is supposed to be. That's not how you're supposed to use a document with a vector database. But like have you ever come across like something where the the client asks you to do something, but it was just like buddy, you shouldn't do that. Like give me like life lessons that you can like teach us where like you've come across like a project where you're asked to do it and you're like, man, this thing sucks. That's not the most optimal way. Something better, something faster, more efficient. Like, do you have any one of those stories?
Yes. So I have two types of those kind of stories, and the reason why I was shaking my head was actually for something else, but I'll tell you I'll tell you after why I was doing it. So the first group is operationally. So the example you just gave, I would fit in that group, right? So that is people who see these embeddings as like a silver bullet. They just throw complete documents at it and what have you, and they and then whatever they try to achieve, that doesn't work. A nice example is that if you, for example, only use LLMs and you have, for example, I don't know, a financial document from Apple, and then on page 192, there's some information you actually want to retrieve. But the only way to know that that page is related to Apple, the company Apple, is because it has the little Apple logo in top of it. But you didn't factorize that because you were using a language model and not a multimodal model, right? So those kind of problems I see a lot, right? So that is the operation. That's also for the database, that people set up the database in a way that's kind of suboptimal, or that people stuff everything in memory because that's easy and it's fast. But then when they grow, they need to be more sophisticated in how they operationalize the database as well. The other group is more, and I don't even know how to call this, but if I give an example, you probably know what I mean. So if you solve problems in e-commerce, CRM systems, banking statements, fraud detection, great. But if you want to say something about like medical records or generate something about like, that has direct impact on people's lives, I'm always a little bit hesitant with these kind of things. And I hope that people keep like humans in the loop before they start to build and sell products that aim to automate that kind of stuff. I think people should be careful with that. And so that's I don't even know how to call it, but it's more like related to how much impact that the products have that people build with these models and vector databases on society. And the reason I was shaking my head is because I think that's our fault / problem, our being the community of builders of products and services. We all got very eager, right? So I remember when the first time OpenAI had on their website, hey, you can use these embeddings with vector databases. They had a very short list. It's now a long list, but on that list, we were on that list too, and I was very proud of that. And all statistics went up after that list was published, and there were like only 3 on them, and we all got very eager, right? And we, and we wanted to, grow our communities and our customer bases and that kind of stuff. But what we sometimes forgot was to help people be actually successful, right? So that we said like, hey, let us help you do these architectures well. Let us help you to understand that if you take this extra step, for example, to implement the hybrid search functionality, you're going to be more happy down the line. If you take this extra step in from an architectural perspective, you're ready for the future when your company grows. And I think we need to make sure that we keep doing that we help people be successful, because we're helping nobody in our category if we don't do that. Because what will happen is that there's the famous hype cycle from Gartner. There's the how they call it, the slope of illusionment or whatever, disillusionment or however they call it. We wanna flatten that as much as we can. And we do that by helping people become successful. And that means we need to educate them, we need to help them, we need to talk to them, we need to make them successful. And that was kind of why I was shaking my head, because I was like, we need to do as much as we can, not only as Weaviate, but everybody who's knowledgeable in this space and building business in this space, regardless if you're a consultant, product builder, there's still a lot of work ahead of us to make everybody successful with these tools.
Yeah, I agree. Like I'd say knowledge, general knowledge on like capabilities, what you can do, being realistic about like expectations on what like Gen AI can do is so important right now because there's a lot of like disillusion, there's a lot of like fantasy around like and hype around Gen AI. So like people think like it's like a one-stop shop for everything. It's still it's a growing field. It's very popular, but there's so much work that's still being done and like there's companies like Accenture where like Accenture created like a thing called Accenture Academy. There's also different academies created everywhere where like they're trying to upskill everybody with like the general knowledge of what Gen AI can do. And I think that like, that's going to be key right now in the future is like upskilling everybody to know like just the basic stuff about Gen AI. And additionally, I think what you were trying to allude at was like previously about uh taking like a prediction and having it output something that could affect your life like the what I think what another analogy or another example I was thinking in my head was that like for like weather prediction versus like credit score prediction, those two are drastically different. Like if it's sunny outside and like the person says it's going to rain, I walk outside and it doesn't rain, I'm not going to care. But if a credit score prediction says that I can't afford a house, that's going to directly impact my future forever, right? So like,
Exactly.
yeah, that was something immediately I was thinking about because that's like it's based on the use case and the sensitivity of the data. So like I think what you were trying to allude at was that like is the data like PII related? And typically if it's PII related or personally identifiable information, like that can impact your life, but everything else, like weather, traffic, that doesn't really impact me that much. Like at the
Yeah,
end.
and I'm not even sure if it's like PI related. It's more, it's even more generic, as in like, how much do I care if the thing is wrong? Right? So if a system gives me 9 out of, like an e-commerce recommender gives us 9 out of 10 times an amazing recommendation, me for example, or you, then we go like, this is amazing. Oh, and this one time it showed me this really weird product. No idea why it did that, right? Who cares? But if with credit scores, for example, if it says, hey, we just want somebody to double check, your request for a for mortgage or whatever, okay, that's fine. But if it says like no, a computer says no because of one of these models, I don't think that's a good idea. Or as I like to say with in the medical domain or something, right? So it's a and um um and what disruption in technology of course does, if we follow the disruption theory, the Clayton's disruption theory, that it kind of attacks the market bottom up. That is, again, that's great from e-commerce to data warehousing to fraud, all these things, right? That's great for that AI. But let's think twice if we do that for things that it has a direct impact on our lives. And that goes back to that educational part, that we need to help people. Like, this is how these models work. I think I'm also, I always tell the people at Weaviate that I say like, well, I said, one of the knee-jerk reactions that we tend to have, and we being not Weaviate, but people working at these startups, is that we want to show off how smart we are. And the way we do that, that's a knee-jerk reaction. We do that by using complex language, complex nomenclature, complex syntax, like, oh, let's build these advanced rack systems. Let me show you like the math that's behind it. But that means that the majority of people can read it and can understand it. And I think the power sits in the fact that we help people to understand how the systems work, how you can make them successful, and what potential limitations are today. So that's kind of why I brought it up. Because it's like, with the door that AI opened. And I mean, we're in the picks and shovels business, right? So we sell picks and shovels to work with AI, but I see like a lot of dollar signs in people's eyes around me. And I mean, again, 99 out of 100 people build amazing stuff, right? But we need to also help this one person to say like, yeah, are you sure you want to do it like this or like that, right? So you need to think about that too.
Yeah. So what I'm hearing is that you're saying knowledge is very important right now, into like upskilling. I 100% agree with that. I also think so. I think knowledge is important. I also think that accessibility is equally important. Getting things more accessible, so that people can use it and build it. That's how this industry is being driven right now. Is that they're taking very complex frameworks and they're distilling it and making it more digestible and accessible to everybody. That's why that in my opinion, that's why I think the Gen AI field is blowing up, is that it just the increased accessibility. But with it comes like you have to have the knowledge on like what you can do with all this tech, the limitations and whatnot. So I think those two kind of go hand in hand. Um, Oh, by the way, I forgot. If I ever needed to get in touch with you, like how would I do that?
It's I'm on like LinkedIn, Twitter, and email. So just good old fashioned Bob at Weaviate.io. Allows you to find me.
Oh, great. And then I'd say like I have a final question, which is like, for somebody who is like an aspiring AI professional, like what advice would you give to them if they're interested in like pursuing a career in AI, especially in the generative AI space because it's so hot right now? Like what would you recommend like them getting started with? Do you think like a Udemy like course would do it? Do you think like just reading documentation on like like a LM like document website would work, or do you think like watching YouTube videos would work? Like what do you think is like the best first step?
Yeah. So first of all, as a quick preamble, it's important for people to know that working with in AI is like with work with software. It's like I always give the analogy, it's like learning to play the guitar. So it takes some time to learn, how to do the fingering, how the chord works, and it takes some time before you can just actually sit down with friends, play a song, right? So that's a steep learning curve. That's the same here too. That's fine. So if you're confused about stuff, if you don't understand stuff, that's fine. That's for so keep going. That's my first advice for people who are really new to this. Um, Secondly is, and that's kind of based how I learned software in general, like that's a long time ago already, but find yourself a use case. That can be anything. That can be if you're still a student, build a chatbot to solve your homework stuff, whatever, right? Or try to make some money out of it, right? So if you build something, and if you're listening to this and you're like 16 years old, find somebody who's willing to pay $500 if you do something with a model from Hugging Face, right? Just they can something because what happens then is that you have a very concrete use case, and that makes it a little bit easier to find your way, to the weeds of information that is online. So I think so. And then when it comes to places, I mean, I I learned the most. How do I learn it? Um, I really like. I'm more somebody who likes written. There's a lot of good blog content on towards data science. Sometimes it pops up through stuff pops up through Hacker News and those kind of things. Sometimes we try to do it on the Weaviate blog. Code examples, the cookbooks work very well that you can find. So just start playing around with it, but ideally with a use case in mind, because it makes it a little bit easier.
So like do you guys have any hot new stuff that's coming on your horizon for Weaviate? Like give me some Philippines, give me some cool stuff that you guys are doing. It's coming up.
Yeah, so I am so the actually the thing that we just released, so that's not spilling the beans, but it's like a kind of thing that we're we're still doing a lot of work on showing people that we have. Is that what I mean in that flat index? So because the big thing is if your use case grows, stuff is in memory, gets expensive quickly, and we're gonna do some great and smart stuff and automatically getting it in and out of memory, doing that over multi-tenant. So especially if you have bigger use cases, a lot of exciting things are coming there as well. We have the new Python client that's going to be that's almost ready to go to be released publicly. The V4 client, same is going to happen for the TypeScript clients. So that kind of stuff, and we now have a big sprint coming up with a lot of stuff around just reliability, scalability, and those kind of things, because a lot of people are now scaling up fast. So those kind of things are super exciting. And oh, and there's something that people will see very soon, a nice collaboration with a famous data warehouse company.
Oh, very cool. Very cool. Well, I'm excited to see that whenever you're free to or like ready to release that info. Just
Soon,
give me a
yeah,
ping.
I will.
Great. So yeah, Bob, thanks so much for being on the show. And until next time, stay curious.
Thanks for having me.